G'day guys, we're going to be looking in this video tutorial at constructing a nut. I'm going to demonstrate it in two different ways, as if it was connected to a bolt or if it wasn't, and I'll show you the difference. But particularly in this, we're going to do an M14 nut, and the construction of this M14 nut is going to be carried across any type of nut that you draw. Although I'm in CAD, I'm going to be talking as if I'm drawing with with normal drawing sets and drawing board material. So without further ado, we're going to start our M14 nut, and the first thing we want to do is work on a circle that gives us a distance, what we call across the flat. So I'm going to just open the material you've got in your book and show you how I'm working with that to find the correct dimensions and do the correct conventions accordingly. Okay. Right, so I'm on your construction page here, and what we actually have here is the construction of a bolt, but the same process is for the nut, and you know it's a bolt because the thread is broken on the inside, or if you like on the crest, sorry, on the root, which essentially means that we're dealing with external thread here, but that's okay. We're going to use the exact same formulas to work for our nut. So if we go back to the drawing, we've got an M14 nut, which means we want to work out the distance across the flat. Now across the flat is what I mean. It's this circle here that is the chamfering towards the six sides. So it actually, what I mean by that is you'll see that it folds over. The material sort of tapers off towards the six sides, and that little line you see along the top over there at the bottom of my italic is the chamfering off, or we call that across the flat. So we're going to go 1.5 times the diameter to create that, and that means we're going to go diameter 14 times 1.5. It's going to give us 21, but we work with the radius, so we're going to make that 10.5 because that's half of the diameter of across the flat. So we said that was 10.5 as the radius. Excellent. And I'm going to go ahead and construct that. So there we have a radius of 10.5, which makes the diameter across the flat of 21. Perfect. So what we're going to do then is we're now going to construct our 30-degree tangential lines to create the six faces of the nut. And I'll show you how we do that now. Right, so what I want to do is just ignore my little hexagon around the side, but I need to set that up just to help me construct this, the next step in the drawing. Okay, so I'm now taking out my 30-degree set square. I've got my T-square running across my board, and I'm going to now construct 30-degree lines that are tangential to the circumference of the circle. But before I do that, I'm going to make it easy, and I'm just going to start on this side, and I'm going to do perpendicular lines, okay, that are tangential. Let me start that one again. That are tangential and come into contact, tangential to the circle, and they are at 90 degrees exactly. So basically what you're doing is you're running a line through the point where the circumference meets the center marking, okay, on both sides, left and right. Then you're going to take your 30-degree set square, as I said a bit earlier, and jump the gun there a little bit. And then I'm going to take my set square, set it up nicely so that my set square just connects my pencil and keeps it at a 30-degree integrity to be tangential to the top left. Now we're going to do it to the top right. Right, there we go. And then we're going to do it to the bottom left and to the bottom right here. So that's 30 degrees over there. Works nicely, brilliantly. And then we're going to do it the same over here. Right, so there I've got nice 30-degree tangentials, and what that then makes is my hexagon. So I'm going to go around and just snip a few of these lines so that you can see the finished product of the outside, the six faces of the hexagonal nut. Right, so there we go. Right, so now what we're going to do is we're going to go and work with the thread. So we've got the measurement in terms of the diameter of the thread, which is the M14. Now the diameter of the thread, the M14, refers to the thread of root to root, and I'm going to show you a quick picture of what that looks like. So if I come across to these little pictures, I just want to give you basic thread terms, and we're going to work with these two terms, the root and the crest being the top of the thread, the root being the bottom of the thread. So we're going to go across to a section of the nut here. Found this on the net and thought it would serve the purpose. So we're working, when we say M14, what we're referring to is the distance between the root there, which is like the bottom of the valley between the crest and crest, down completely vertically opposite to that root over there at the bottom portion. Okay, so that's root to root. Now that's what the M14 refers to. Okay, so what we're going to do now is go and set that in place. So the M14 is the diameter, so we work with radius because we've got a compass. So we're going to open up to a distance of 7 mils, and we're going to construct that circle. Right, then we're going to go ahead and then construct from crest to crest. Now, crest to crest, how do we work that out? Well, the diameter is 14, and what we're going to do is we're going to times the diameter, which is 14, by 0.1. That's the formula. That gives us 1.4, but we're going to round that off to 1.5. Remember, we work with radius. We don't work with diameter with our compasses. So the radius then here would be we'd substitute 7. So we take 7 minus 1.4. So 7 minus 1.5, sorry, because we're going to work with a slightly rounded number. And that's going to give us 5.5. So 7 minus 1.5 gives us a total of 5.5. So we're going to open up our arc, our compass, to 5.5. Right, and there it is. And it gives us a nice little arc around there. Now, let me do that again. See what happens if I go and connect it point to point, because it's not a circle. It doesn't want to connect. So I'm going to go open again to 5.5. Right, and then run that all the way around, almost connecting. You'll connect, but I won't here. Okay, so what I'm going to do here is I'm going to demonstrate the difference here. As if you have a nut on its own, guys, you are then going to break this line over here in the top right quadrant. So you will rub out a portion of this line, okay? And that will be, I don't know if I can do it manually here. I don't want to change the, okay, yeah, it's not going to work. Okay, so if it was the nut on its own, and that would be meaning you would be representing internal thread. Okay, because you cannot see the thread from the naked eye unless you tilt it at a 30-degree angle and look down diagonally into the nut. If you look at it flush like that, you actually can't see the thread, which means we are dealing with internal thread. So that means the root you will demonstrate is broken. But remember, in this case, when we're working with mechanical assemblies, the nut is always fastening a mechanism to a shaft. So in this case, if we were looking straight onto this nut, we know that a shaft would be coming towards us through the nut. And when we have a nut, a shaft of any sort with thread on, we look at the shaft with the naked eye, we can see the thread on the outside, which means it's external thread. And so when a shaft and a nut are assembled together, the overriding then is external thread. So what we do is, I'm just going to use a little circle here. You won't do this. I'm making like a little manual rubber, excuse me. Let me do that again. You're going to then break this section of the line in the top right quadrant. So let me just move my circle over a little bit to give a better representation. There it is. So what I'm going to do now is I'm going to go break this line to represent external thread. Okay, so let me just do that there. It's going to move that circle. So I just did a manual rub out. So now that represents the fact that a shaft is coming through the nut. Remember, if the nut was on its own, this would be closed and the root would break in the top quadrant. So we break the crest to show that there's a shaft running through the nut. Now we're going to go ahead and construct 3 sides of the nut on the same center, on the same axis over here. So without further ado, let me do some construction lines and I'll explain what they are. Right, so what we're going to do here, you can see that I've taken the corners or the points of the 3 faces that we need to draw, and I've extended some construction lines across. I've just gone any distance for all of them. There's no distance that you need to go unless you've already drawn the one view or they give you starting points. Now, they're probably going to, in the question, give you the height of the nut. But in this case, I'm going to pretend they did not. So we've got an M14, and to work out the height of a nut, we go the diameter, or M14, diameter of root to root, and we're going to times it by 0.8. That gives me an answer of 11.2. So I'm just going to work with 11 as a round number. Okay, so we want a line. So I'm going to get a nice blue line of 11. So I'm going to start over here and run it down. And then I'm going to, you guys will just run obviously another line at 11 millimeters away, but I'm just going to quickly offset a line. Okay, 11 millimeters. So in between those two lines, I'll have three faces of my nut. So you'll see already we've got a face will fit in that little rectangle there. A face will sit in this little rectangular portion here, and a face will sit in that rectangular portion over there. Now we're going to go and use a technique to create the faces perfectly. Right, now because we have the nut line basically on its side and horizontal, we're going to use a 30-degree set square again. And what I'm going to do is I'm going to run a line from the top outside corner at 30 degrees. You don't have to worry about how far you go, just make sure it's 30. Right, I'm going quite far. Right, so I'm going to do the same thing from this side, make sure I get a nice 30-degree line. And what we want is we want an intersecting point over there, because that's going to be a nice little compass point in which we will arc. Then we're going to go to the inside and opposite corner of that face, right? Inside and opposite corner, and we're going to run another 30 degrees. And we want to find a nice another little intersecting point over there in that quadrant, in that little rectangle. And then we're going to do the same from the inside bottom corner, rectangular section of the nut or face. And we're going to run out at 30 degrees. Let me just do that again. So in this lower face, inside corner, 30 degrees. And that's what we should have. Okay. So now what we're going to do is we're going to take out our compass and we're going to create the tapered faces. We want to use our blue because that's what we're using for our finished color here. Right, so I'm going to open up my compass and I'm going to start there, right, and open up that full distance over there. And I'm just going to do a quick cheat so that I can show you how to do it manually, otherwise it will be impossible for me. Right, so I want you to ignore the little arcs that I've already got in. Those are just to guide me because I'm having to try to do this manually. So we're going to open up our compasses on our given intersecting points, right? We're going to open up so that we connect our compass along a horizontal plane on the top of that face, right? Right on the top, and then we're going to arc to the left and we're going to arc to the right, or arc from top to bottom. We're going to do the same thing on the other side, so let's stay consistent with the little sections we work in. Let's go to the furthest face. So we're going to start there, right? Put our compass point on there, and that's where we're going to work. We're going to start there, extend nice and horizontally across the page to meet the top of that face, or the left side of that face, depending on the way you view it. And then we're going to arc all the way through to the other side. Right, and make sure that we tangential. That's why we need to start on that point. Okay, then we're going to go do the same thing, right? And we're going to go do it from this point over here. But now we're going to work on a bigger scale, but we stay horizontal. We don't go off that horizontal plane, right? And we start with our compass there. We're going to arc all the way to the left, and then we're going to arc all the way back to the right, or from top to bottom. And there we have three faces of our nut. Let me just create the little corners here or edges just to keep it consistent blue so we get a good picture. Right. We've got three faces. There's one more thing we need to complete, and that's two 30-degree or 60-degree lines, depending. It'll be 60 degrees because of the angle at which the nut is at the moment. But we need to create that little chamfer from the side. This only happens if you are looking at it with three faces. So we want a nice 60-degree line. Okay, so in this case, I'm going to go 180 divided by 60 gives me 120, because that's how CAD works. There we go. And we want to go to the top here, and we're going to do the same thing. Right? 120, there it is. Perfect. So now we've got these little tangent. I'm going to go and just edit those so that you can see what that refers to. So we've got these little chamfers over here at 60. Sorry, I've gone one too far. That's how we want it, just as you see it there. Give me a sec. Right, that's what we want to see. that little 60 that was a 60-degree chamfer, but if the nut was the other way around, it would be 30 degrees. Okay, so there we go. Let me just clean it up over here just so you get an idea of what that chamfer actually looks like on both sides. Right, there we go. Then obviously this will all be construction. That goes away, and this little portion here goes away, so that we have that lovely little finished off portion of the nut. And there it is. So that is your nut in the front view with a shaft through it for an assembly, as well as a 3 faces of a nut on the side view. I hope this little video tutorial has helped you guys to refresh you, for those of you who've forgotten how to construct it, and for those of you who are new to the subject. But enjoy it, guys. Any issues, any queries, just text me. Fantastic. Cheers.